Okay, so continuing where we left off, we just talked about disjoint events and how to calculate the probability of them. And so let's look at, non-disjoint events. Suppose that a card is selected from the standard 52 card deck. Compute the probability of the event E, drawing a king, or F, drawing a diamond. So we are looking at 52 cards. We want to know probability of E or F, which is union F. E being king, and F being diamond. Okay, so some things to know. There are 4 suits, which means that there are 52 cards, so 52 divided by 4 is 13. There's 13 of these. There are also 13 different faces, whether they're numbers or face cards or whatever they are, ace. And so there are 4 kings in a deck. So that means that P of E union F is equal to P of E plus P of F minus P of E intersect F. Because remember, there is a king of diamonds, so he would fall into the intersection. So this is 4 out of 52 plus 13 out of 52 minus 1 out of 52, which is 16 out of 52. There is a 16 out of 52 chance that you get a king or a diamond. Okay, with that being said, let's move on next. Contingency table is a table that relates 2 categories of data. Row variable is the label for the rows, and the column variable is the label for the columns, obviously. So you can see here males is the label column for the column variable, and married, never married, widowed are the row variables in this case. So now we're going to do some probabilities. I say determine the probability that a randomly selected U.S. resident is 15 years or older. So to do that, we need to get all the males. I'm going to do that with the calculator right here sitting on my lap. So give me 1 second. We have 41.6, 64.4, 3.1, 11, and 2.4. So there are 122.5. So we're moving on. Let's clear this. 122.5 males. This is part A of this question. Out of 251.3 million, I believe it was. If it's not, then oh well. We'll just, obviously, if you wanted to find out of everybody, you'd add all the females together, add that to the males, and that would tell you the total. I'm pretty sure it's 251.3 though. Determine the probability that a randomly selected U.S. resident is 15 years or older or widowed. So that's widowed is 3.1 for males and 11.2 for females. So we can add those together and we get 14.3 out of 251.3. Part C. Oops, sorry, I keep going to the wrong thing. Part C. Determine the probability of a randomly selected adult being 15 or older is widowed or divorced. 15 years of older, you want widowed or divorced. So we said widowed is 14.3, divorced is 25.4. And that gives us a total of 251.3 out of 39.7, or I'm sorry, 39.7 out of 251.3. And the probability that a 15-year-old is male or widowed. Well, we've got male and widowed from earlier, so male was 122.5 or 122.5. Widowed is 14.3. So we have 8. 2 plus 4 is 6. 3, 136.8 out of 251.8. So we've got the calculation for that. Almost 50% of the people on this. Okay, and then finally we're going to talk about complements. The complement of event E is the complement of an event is denoted e to the c power, which means E complement is all outcomes in the sample space that are not outcomes of E. Therefore, E and E complement are mutually exclusive, and the probability of E or E complement is equal to P of E plus P of E complement, which is equal to P of S, which is the entire space. So what that means is it's basically like if you had 100, or let's say I had $100 and I gave you 50 of it. Then what is gone from so what is in the complement of what I have left? It would be the 50 that I gave you. If I gave you 48, then the complement of your 48 would be my 52. If I gave you 25, then the 75 remaining would be the complement of what I gave you, and so on and so forth. So it's just whatever's left over, anything. It doesn't matter if it's in another subset. It could be in subset F. As long as it's not an E, it is in the complement. So it says, according to a national gambling impact study, 52% of Americans played state lotteries. What is the probability that a randomly selected American has not played the state lottery? Well, that's easy to figure out, because if I gave you $52, I have, out of the 100, I have 48 left. And so 48% is the answer to this question. It's anybody who has not played. And so for this one, this is where it gets really helpful to have a complement. It says, compute the probability that a randomly selected household earned the following incomes: 200,000 or more. Well, all we need to do is add up all of the values, which I'm going to do real quick. We have 8, 9, 40, 6, 6, 9, 3, 13, 8, 9, 8, 12, 6, 7, 8, 2, 1, 6, 5, 9, 6, 6, 6, 4, 6, 3, and 5, 9, 1, 3. Normally we would do this in class, but since we are in class, we have a total number of 122,953 households. 200,000 or more, there are 5913. If we divide that, I'm just doing it this time because we probably should do it just to practice. 122,953 is equal to about 4%. 0.481. Okay, so there's the first one. The second question is less than 240,000. Or I'm sorry, less than 200,000. Well, that's easy because 200,000 is this one, so that's everybody left over. So all we need to do is we do 122,953 minus 5913. 122,953. So if we subtract that, we have 122,953 minus 5913. This is 117,040, which if I do 1 minus 0.0481 gives us 0.9519. That should be the answer for that one. And then finally it says at least 10,000. At least 10,000 is everything except for less than 10,000. So what we can do is the same principle. We can do 122,953 minus just 10,000, less than 10,000, which is 8,940. 122,953. Sorry, that's hideous. Which is 122,953 minus 8,940 divided by 122,953 is 0.9273. 0.9273. And so I hope you guys practice. Make sure you do the student practice. I've written the solutions on Canvas. Obviously do the homework. You should be, I'm hoping you'll be able to get this pretty easily. If you're struggling, make sure you're attending Zoom meetings and asking questions. Thank you guys for watching. Have a good day.